In section 1.4, we are dealing with radical equations. We'll start our lesson with some examples of solving radical equations, and then we're going to look at some equations that are quadratic in form. Those are going to be fourth degree polynomials that we are going to factor just like we did when they were quadratic polynomials, trinomials to be exact. And so that's what we're looking at today. So let's get started with how to solve these radical equations like we're looking at here. So to undo the square root of 5t plus 3, we're going to do the squaring of 5t plus 3. So if you want to undo a square root, invisible 2 there, then you will square. If this had been a cube root, so I can put it back. If this had been a cube root, you'd be raising it to the third power. So let's see what we get when we raise both sides of this equation to the second. We get 5t plus 3, and we get positive 4 on the right. Okay, so now we're back to basics of solving for t. So we're going to subtract 3 from both sides, divide by 5 on both sides. And this is very important. When you get a solution, or we think it's a solution, it's very important that you test your solution back in the original problem. There are times when we think we have a solution, but when we try it, when we plug it in, it actually doesn't work. That's called an extraneous solution. So let's go back to the original problem, and let's replace t with 1/5 and see if we get -2 as a result. Well, right away, you could probably tell in the real number system, it's not possible to do the square root of anything and get a negative result. So that should have sent a red flag right away. But let's just go ahead and finish it. 5 times 1/5 is 1. 1 plus 3 is 4. So we want to know, is the square root of 4 equal to -2? Obviously it is not. So we came up with a possible solution, but when we checked it, it didn't work. So our conclusion here is that there is no real number solution. And you're going to have a few like that. So it's very important. Don't just assume that your solutions are legitimate. You're going to, even if it's just a mental check, a visual check, you need to make sure that your solution makes the two sides equal when you replace the variable. All right, let's try this one. Whenever a radical has addition or subtraction involved, we need to isolate the radical first. So in this particular problem, we need to do a quick little step before we start raising both sides of the equation to the third power. All right, that's an important first step. Now we're going to get rid of or undo the cube root of by cubing, and we're going to do that on both sides. So the effect on the left side is to get rid of the radical. So we're left with just 1 minus 2x, and 3 cubed is 27. And now we're back to familiar territory, solving for x. We subtract 1 from both sides. We divide by -2 on both sides. And our solution, we think, is -13. But let's check it out. So go back to the original problem and replace the variable x with -13. Subtract 3. Do you get 0 when this happens? So let's see if we can do some mental math. This is going to be 1 minus -26, which is 1 plus 26, or 27. The cube root of 27 is 3. 3 minus 3 is 0. So in this particular case, we get a legitimate solution. Our answer is x equals negative 13. Okay, this time we're going to do, we don't have to do any isolating. We don't have to undo addition or subtraction. So we're going to square both sides. And that's going to leave us with 15 minus 2x equals x squared. So the presence of a single x squared in an equation like this means we're going to have a quadratic equation. And you should always train yourself to just let quadratic equations equal 0. So I'm going to add 2x to both sides. I'll subtract 15 from both sides. Oh, not sure what happened there. And now we have a quadratic equation set up to, hopefully we can do factoring. If factoring is possible, and I think they're all going to be possible in your assignment, then that is definitely my preferred way of solving. So let's solve by factoring. Let's look for the factors of negative 15 that add up to positive 2. And that would be positive 5 and negative 3. So the solutions that come out of the factoring are negative 5, x equals negative 5, and x equals positive 3. So let's check these out. Do a little quick check here. So 15 minus 2 times negative 5. Does that equal negative 5? Well, we already looked at earlier that the square root of a number cannot be negative, and that we could go ahead and prove it. This is going to be 15 plus 10, which is 25. The square root of 25 is not negative 5, it's positive 5. So negative 5 isn't a legitimate solution. It's called an extraneous solution. So now let's try 3. If we put 3 into the, again, it's the original equation, does the left side equal the right? So this is going to be 15 minus 6, which is 9. The square root of 9 is 3. So we got 2 solutions, but as it turns out, only one of them is actually correct. And so my answer for number 19 is x equals 3. Number 23, again, we're going to square both sides to get rid of the radical. And you want to be careful on the right side. On the right side, we have this situation that is, in my experience, one of the most commonly made mistakes in algebra. And that is taking a binomial like this and squaring it and getting x squared plus 4. And this is so bad, okay? You need to resist the temptation. We've talked about this a lot in Algebra 2. You have a choice. You can either do what it says, multiply x plus 2 times itself with FOIL, or you can do that mental math, 3-step mental math process, which says square the first term, multiply these terms together, and then double that result, and then square the last term. Now, if you went through the FOIL process, you would have gotten the same thing, but please resist the temptation of just very simply squaring both terms. If you square a binomial, you should always have 3 terms as a result. All right, when I subtract x squared from both sides, they're just going to cancel. So I'm going to add x to both sides, and then I'm going to subtract 4 from both sides, and then divide by 5 on both sides. And you would now, I don't want this video to get too lengthy, but you now want to plug in negative 8/5. And if it helps, because you can use your calculator for this, if you want to turn negative 8/5 into a decimal and then plug that in to get the result, that might be a little bit easier for you than dealing with fractions. I'll leave that up to you. but this does work if you plug it in. Negative 8/5 is a legitimate answer for number 23. All right, in problems like this where there are two radicals in the problem, we want to put these radicals on opposite sides of the equation. So that needs to be step number 1. So I'm going to add the square root of x minus 1 to both sides. So two radicals in the same equation, those radicals need to be opposite each other on either side of the equal sign. Now we can square. All right, and I'm going to get 3x plus 1 on the left. And here we are again, we got a binomial, so we got to be careful to square it correctly. So square the first term, multiply these two together, and then double that result. So that's going to be 4 times radical x minus 1, and then square the last term. And if it's okay, I'm really didn't allow myself a lot of room because there's some work involved in this. So I'm going to go to a new slide, and we'll pick up from here on a brand new slide. Okay, so now let's do some cleanup. We can combine like terms on the right. We have a couple of constants. So I'm going to make negative 1 plus 4 go together as plus 3. And now we're back to familiar territory, sort of what we did at the beginning of this lesson. We need to get this radical. Really, I'm going to work on getting this isolated. So the radical, anything that's being added or subtracted to a radical expression needs to be removed so we can solve. Okay, so I need to subtract x, and I also need to subtract 3. And now we've set it up to solve it pretty easily. And we're going to go ahead and square both sides. So I'll make sure you understand when you square this whole side, we're going to be squaring the 4 and the radical. And since these are being multiplied together, once we square both, we need to multiply those results together. We'll take a look at that. All right, so let's square both sides. So first term squared, that's 4x squared. Multiply the terms together, that's negative 4x times 2 is negative 8x. And then square the last, that's plus 4. So I'll come over here to the side for just a second. Square the 4, square the radical, and then multiply those together. And you get 16x minus 16. So that's how you treat the squaring of a product where one of your products is just a whole number and the other is a radical. You just treat them as two separate squarings and then multiply those two results. All right, looks like we're in line to solve a quadratic equation. So let's make it equal to 0. Subtract 16x, add 16. And we'll do some factoring. There's a GCF of 4. That'll make our factoring quite a bit easier. And now I'm going to factor this quadratic trinomial using the factors of positive 5 that add up to negative 6, and that's negative 5 and negative 1. So I got two possible solutions, but I need to make sure that they're both legitimate. So let's test x equals 5 in the original. All right, go back to the original problem. So let's see if we can do some mental math here. This will be 15 plus 1, that's the square root of 16, minus 5 minus 1 is the square root of 4. Does that equal 2? So 4, square root of 16 is 4. 4 minus 2. All right, so 5 checks. 5 looks good. All right, now let's take a look at 1. So 3 times 1 is 3 plus 1. So this is going to be the square root of 4. 1 minus 1 is 0, and the square root of 0 is 0. Does that give us 2? So the square root of 4 is 2 minus 0, yes. So in this case, it doesn't always happen, but in this case, they both work. So we got 2 solutions, and they're both valid. All right, number 31, similar process. We're going to square both sides. When I do, this top side, this bigger radical is going to go away. And on the right side, it leaves us with just x. So you always want to undo any addition or subtraction on the same side that you have a radical. So I'm going to subtract 3 from both sides. And now you're ready to square both sides. So again, square the whole number, or the integer. Negative 2 squared is 4. Square the radical, that would be x, and then you just multiply those two results together. So there's the result of squaring the left side. And then here we are again squaring a binomial, and that's x squared minus 6x plus 9. Another quadratic equation that we will attempt to solve with factoring. So let's make it equal to 0. Subtract 4x. And sure enough, it factors. The factors of positive 9 that add up to negative 10. So I got 2 possible solutions. I just want to make sure that they're both legitimate. So let's check 9. So let's see. Change some colors here. Try to squeeze this in. If we let x be 9, what do we get? Okay, well, let's start here. The square root of 9 is 3. 2 times 3 is 6. 3 minus 6 is negative 3. So we're going to be doing the square root of negative 3, which isn't a real number. So 9 doesn't work. All right, let's try 1. All right, start with this inside radical. So the square root of 1 is 1. So 2 times 1 is 2. 3 minus 2 is 1. Square root of 1 equals the square root of 1. So this one is good. This one made the equation, the original equation, balance. So we got 2 possible answers, but only one is valid. All right. Now, when you have expressions where the exponent is a fraction, this is just another way, fraction exponents are another way of writing radicals. So I'm going to put in green an equivalent equation. These mean exactly the same thing. So the process is the same. I'm going to raise both sides of this equation to the 3rd power. And when you raise 1/3 to the 3rd, you multiply exponents. That becomes 5x minus 2 to the 1st. And this is 8, 2 to the 3rd. And now it's pretty easy. You add 2 to both sides, divide by 2. And let's see if it works. So 10 minus 2, do the parentheses first, is 8. And this means the cube root of 1/3 as an exponent means the cube root of 8 is 2. So that works. All right. Again, these are really radicals. And so if you want to change them into radicals, you're welcome to do that. in radical form, this would be the bottom number of this fraction is the root, and the top number just stays with x as an exponent. So that's another way of saying the square root of x cubed. And this would be 3 times the square root of x. So if you want to change problems like this, if you would prefer to change them into radical form, that's fine. We need to put the radicals on opposite sides. And now we can square both sides since they're square roots. So this is going to be x to the third on the left. And going back to what we talked about earlier, do each of these separately and then multiply the results. So 3 squared, 9 times x. And let's set this up to also solve by factoring. So I'm going to make it equal to 0. And I can factor out a GCF. Always think GCF when factoring. Make that your first thought. And I can factor this as the difference between two squares. So I got 3 solutions. That tells me I'm looking for 3 solutions. So each one of these factors need to be set equal to 0, and that will represent our solution. So x equals 0, x equals -3, and x equals +3. All right, so let's check these out and see if they actually work. And you can use either form. I'll just use the radical form. This is the square root of 0, which is 0. This would be -3 times 0. So x equals 0 is legitimate. You can already tell that if you use -3, you're going to be doing the square root of a negative number, which is not real. So that's going to cause problems. You don't really need to calculate that. And then 3, if x is 3, this would be the square root of 27. Up here. -3 times the square root of 3. Does that equal 0? Well, the square root of 27 in simplified form is 3 root 3. So subtracting anything from itself makes 0. And so we got 3 possible answers, but only 2 are valid. Okay. Now we're dealing with, these are called quartic trinomials. Quartic is just another word for 4th degree. The good news is if you understood how to do the quadratic form of these, which I'll just show the quadratic counterpart, because we're familiar, we've done a lot of this in Algebra 2, factoring quadratic trinomials and then solving. Well, you factor these quartic trinomials the same way, identically, same way. It's just that to make them 4th degree, these x's need to be raised to the 2nd power. So everything is just like it used to be when they were quadratics. It's just that now your x term is going to be squared. And we're looking for 4 answers. So let's take each of these factors and make them equal to 0 and solve. So doing the square root of both sides, I'm going to get plus minus 2 out of this. And I'm going to get plus minus 1 here. And these are all 4 legitimate answers. Just try to save a little bit of time. And then this would be the box method. So when this was quadratic, we would have used the box method. I'll just go back to familiar territory and show you how it relates. So we did the multiply those together, and then come up with the factors of that product that add up to the middle. That would be negative 3x times x. And now find the GCFs, 3x and 1, x and negative 1. And that would be the factoring, but since it's fourth degree, we just have to include x squared. X squared. All right, now solve each. Now the instructions in your book say to find the answers in the real number system. So when you run into situations like this, when you're going to be doing the square root of a negative, that's not real. So in this particular exercise, you don't have to worry about those answers. Your answers are only going to be real numbers. All right, so the square root of a negative is not real. So my only answers that are in the real number system would be positive and negative 1. All right, that concludes the notes for section 1-4. I hope you feel prepared now to do some practicing with the assignment. If you need help, come see me, and I will see you next time.